Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
Voyager 1 will conclude its 50-year space mission on September 5, 2027. It should reach 176 AU as of right now, or around 24 AU, given its present speed of 38,000 miles per hour. Avoid the sun for many hours. It will take 300 years to reach the inner Oort cloud area and 40,000 years to reach other stars if it continues to travel at current speed. In the ensuing billion years, though, where will it go? Stroll, what is it he will see? But first, let's go back before responding to these queries. Voyager 1 and its twin, Voyager 2, are primarily designed to conduct space exploration. The primary goal of Voyager 1 was to closely examine Jupiter, Saturn, their moons, and their magnetic fields. Its orbit was scheduled to pass by Saturn in November 1980 and Jupiter in March 1979. Fascinatingly, the spacecraft's cameras recorded Jupiter's weak rings, enormous storms, and atmospheric patterns after it arrived at the planet. Examining the specifics of the Great Red Spot, one of the biggest storms in the globe, is one of the mission's highlights. Additionally, Voyager 1 focused on Jupiter's moons. He discovered that Io, which displays the eruption of volcanoes and enormous lava flows, is the solar system's most active body. Furthermore, images of Europa reveal a smooth ice surface, raising the prospect of an ocean beneath the icy crust of the moon. Voyager 1 arrived at Saturn a year later. The structure of Saturn's rings may be seen in the spacecraft's photos along with other smaller rings and ring gaps, including the hitherto unseen F ring. Similar to Jupiter's moons, Voyager 1 offered comprehensive data on Saturn's moons. Titan, Saturn's biggest moon, has a rich orange color, which may be the most significant finding. Complex organic compounds are present in dense areas that are rich in hydrocarbons and nitrogen. Nearly 10 years later, in 1990, Voyager 1 started the Voyager interstellar mission, which was intended to investigate the heliosphere, the western frontier of the universe, and initiate interstellar travel. Also, this is the well-known pale blue dot picture location. After 8 years, Pioneer overtook the 10 to claim the title of largest producer. On February 17, 1998, Voyager 1 overtook Pioneer 10 as the object built by humans that was farthest from the Sun. Voyager 1 was at that point around 69.4 astronomical units, AU, away from the Sun. At this milestone, Voyager 1 was approximately 6.4 billion miles, 10.3 billion kilometers from the Sun. Approximately 15 years later, on August 25, 2012, it passed through the heliopause and entered the star's center, where cosmic rays, magnetic fields, and the interstellar medium are present. The astronomical unit is the distance between Earth and the Sun, which is approximately 93 million miles, 150 million kilometers. It gave us the first direct measurement of its density, which gave us some understanding of it. What interstellar space is like? The distance between celestial bodies. With a diameter of around 3.7 meters, Voyager 1's high-altitude antenna serves as its means of communication with Earth. The aeroplane can send and receive signals into space thanks to this antenna, which targets weak radio waves. Its lone communication partner is the Deep Space Network, which is among the biggest radio networks in Australia, California, and Spain. In order to guarantee that at least one station is constantly aligned with every aircraft as the Earth spins and enable continuous communication, each station is positioned roughly 120 degrees apart with respect to Earth longitude. This is how these massive dishes communicate with the Voyager space probe, and they can do the same with spacecraft millions of kilometers distant. The signal takes around 20 hours to reach Earth, traveling at the speed of light. This is because radio waves, which move at the speed of light since they are not a kind of electromagnetic radiation, are transmitted to Earth by Voyager 1 using a high-speed antenna and a narrow beam. An aircraft's radioisotope thermoelectric generator powers its communications and operating systems. These generators provide the energy needed to run Voyager 1's equipment, onboard computers, and radio transmitters by harnessing the heat produced by plutonium-238 decay. ARGs lose around 4 watts of power a year, and their half-life is estimated to be 87.7 years. It is anticipated that until 2025, Voyager 1 won't have enough power to sustain the functioning of every scientific equipment. We will not get any further information or signals from Voyager 1 as it continues its quiet voyage across space from this point on. On the other hand, Voyager 1 was equipped with the Golden Record, a 12-inch copper disc coated in gold that contained sounds and pictures showcasing the variety of life and culture on Earth. This is a record of all aliens or a time capsule that will be seen to future generations of humans. Recordings of greetings in 55 languages, music from many eras and civilizations, noises from around the globe, and a variety of photos illustrating life and the human condition are all included. Can Voyager 1 travel very far? In reality, given the size of space and the orbit of Voyager 1, it is expected that heat cycles, cosmic radiation, and micrometeoroid encounters may cause modifications to Voyager 1 over time. It is susceptible to the gravitational pull of a planet or star. Thus, the structure of Voyager 1 will probably be dated to hundreds of millions to thousands of years ago, excluding the tremendous annihilation of items. It will have seen numerous stars by then, but it will only have traveled 5 trillion miles or 1.7% of the Milky Way's circumference. During its lifespan, Voyager 1 will most likely travel past the galaxy stars Hercules, Lyra, Cygnus, Draco, and Camelopardalis on its present journey towards the star Ophiuchus. This constellation has somewhere between 1,000 and 10,000 stars. It is important to remember that thousands of years ago, objects like sunlight, molecular clouds, and even the Milky Way itself would have had an impact on the aircraft's trajectory. Tides? Voyager 1's path will be altered by the Milky Way's gravitational pull, and that of other galaxies and interstellar objects as they spin. Over billions of years, even these little short-term alterations can result in major variances. The stars themselves will also diverge from their present locations over a very long time, and when new stars are formed, the stars as we know them will either alter or disappear from their original roles. Constellations. The future's galaxies will differ from the ones we see now because the old in its current form must die. Predicting Voyager 1's path is a probability exercise due to these uncertainties. Its long-term orbit and circumstances will also be influenced by its interactions with the interstellar medium, which include contact with gas, dust, and other components. The spacecraft may also travel through denser portions of the Milky Way, such as the potential region close to the Milky Way's center or the outer halo gap, each with unique gravitational characteristics. However, the spirit of exploration and discovery that characterizes mankind in our pursuit of knowledge and understanding is still inspired by Voyager 1's voyage. Unknown to the outside world,